Welcome to AT Math Academy. Today we are going to verify some more identities. So one of the trigonometric identity with cosine ratio is cos of a plus b is equal to cos a cos b plus sin a sin b. So we are going to see how this identity is formed and derived. So let's take the circle on the coordinate axis. So imagine this is a coordinate axis and here is a unit circle. So I'm going to draw two rays. So this is one of the ray and this is one of the ray, and this ray here is making an angle A, and let's say the second ray is making an angle of B. Then if we want to write the coordinates for this point and this point, it will be cos of A and sine of A, because x coordinate is represented with cosine and y coordinate is represented with sine. And since here it is making an angle of B, I'm going to write the coordinates here as cos of B and sine of B. So in this case, I'm going to draw one more ray here, and this angle I'm going to show it with my dotted line. So this can be marked as angle A minus B. So A minus B. Then my coordinates over this point would become cos of A minus B and sine of A minus B. Okay, and as this is a unit circle, so everything that is dropping down here, this radius length from the axis to this point is 1, and this is on x-axis, so the y-coordinate is 0. So I'm just going to redraw it here again, the coordinates. So this is my coordinate plane and this is a circle. So I'm just going to take my 1 point of cos of A minus B and sine of A minus B. So I'm just considering this coordinate here and dropping the line here. Here I have my 1, 0 for the unit circle. Okay, so now I'm going to write my distance formula here. Say suppose this line joining here, the coordinates of cos A minus B and sin A minus B and 1, 0. Let's denote this distance with D. And we all know that distance between 2 points, for say the points are x1 and y1 and x2 and y2, then the formula for finding the distance is square root of x coordinates difference x2 minus x1 whole square plus square root of y coordinates difference, sum of squares of x coordinates plus y coordinates. Here my points are cos of A minus B and sine of A minus B. Let's say these coordinates are denoted as x1 and y1, and my another point is 1, 0, which is denoted as x2 and y2. Okay, or you can denote it in a different way. Maybe you can take this as x2 y2 and this as x1 y1. Let's do this way because this is a unit circle, so my first points will be 1, 0 and the second point will be this. So let's now apply the distance formula here. Let's say distance, this length is denoted as D, and the distance between 2 points here would be D is equal to square root of x2, which is nothing but cos of A minus B minus 1 square plus sine of A minus B minus 0 square. Okay, and when you do this, this is the distance between these 2 points. And say suppose from the first loop here, first circle, I have 2 more points here, A and cos A sin A and cos B sin B. From this, if say this line joining these 2 points is again denoted as D, and I have my distance between these 2 points can be written as D is equal to square root of cos A minus cos B square plus sin A minus sin B square. Okay, so this is again the distance between these 2 points. So now I have 2 formulas for the distances. So from equation 1 here for the first points, and this is my equation 2 for the second points. Now what I'm going to do is I'm going to equate these 2 points here. So when I do that, I'm going to get it as square root of cos A minus cos B square plus sin A minus sin B square is equal to the second equation, which is cos of A minus B minus 1 square plus sin of A minus B square. Okay, so 0 would be 0, so I'm not taking that. So now when I do this, I'm going to apply the squaring on both sides in order to remove the square root. So squaring on both sides. So when I do this, I'm going to remove the square root, and my value would be cos A minus cos B whole square plus sin A minus sin B whole square is nothing but cos of A minus B minus 1 square plus sin of A minus B whole square can be written as sin square of A minus B. And now I'm going to elaborate this. I'm going to apply the formula of cos of A minus B here, A minus B whole square, which is nothing but A square, which is cos square A plus B square cos square B minus 2 times cos A cos B. And same here for sin square A plus sin square B minus 2 times sin A sin B, and which is again equal to, here this is taken as A and this is taken as B. In that sense, it will be cos square of A minus B plus 1 minus 2 times cos of A minus B plus sin square A minus B. So when I'm trying to simplify this, in my previous videos I have shown you my identity of cos square theta plus sin square theta is equal to 1. So let's put it in the box here. So I'm going to apply this identity over here. So cos square A plus sin square A, that becomes 1, and cos square B sin square B becomes 1, and minus 2 cos A cos B minus 2 sin A sin B. So let's write that down. Cos A cos B minus 2 sin A sin B is equal to, here cos square A minus B sin square A minus B, that becomes 1. One more 1 here, and minus 2 times cos of A minus B. So this is equation, and there is 2 on the left side and 2 on the right side. So 1 plus 1 is 2, 1 plus 1 is 2, gets cancelled out, and we are left with these 2. So when we are left with that equations, I am going to take minus 2 as common here. This leaves me with cos A cos B plus sine A sine B, right? And here I have it as minus 2 times cos of A minus B. So minus 2 gets cancelled out, and I'll be left over with cos of A minus B is nothing but cos A cos B plus sine A and sine B. Hence, I have proven my identity here. So this is how you prove the trigonometric identity. This is the entire recap of my solution, and hope you all like my video, and please subscribe to AT Math Academy, and thank you for taking time to watch my video, and enjoy doing math at AT. Thank you.